everyone. I have been having a heck of a day with technology, getting things to work properly for me. I recently updated my computer to Windows 10, which I like pretty much so far, but all the programs I had didn't exactly, my guess would be prepare for the transition. So my drawing program was fritzing all over the place. I'd be trying to write something as simple as hello, and I'd be writing it right where you see it now, but it would start writing it over here. So the calibration was way off. First I thought the problem was with my tablet and my pen, so I was trying it out in other programs. I was trying to reconfigure everything, but it was just the drawing program itself, for some reason, was not writing where I wanted it to write. So I kind of gave up on it and I just got rid of it. So now we're in OneNote. Then I was having problems with my recording and screen capture program. So that I had to uninstall and reinstall, and thankfully that's working now, so I didn't have to find a different one of that. But I am just ready to finally get into some math. So let's start off by looking at the word problem that I left you with last time. We had a swing at an amusement park that could take 64 people on each ride, and there were a total of 8,983 people on that ride in a day. All the rides were full except for the last ride. We want to figure out how many rides were given, how many people were on that last ride. So since we've got a total amount that we want to break up into equal parts, we are going to be doing division. And the fact that it tells us that the last ride isn't completely full kind of keys us into the fact that we're going to have a remainder. And that's going to tell us how many people are on that last ride. So I start off the division. I can't divide into the 8, so I have to do 64 into 89, and that goes in one time. And then I set up my subtraction, and I get 25. I bring down my 8, and it becomes 258. Now to use my little estimating trick, if I think about 60 going into 260, that would go in about 4 times. So I'm going to try 64 times 4 and see how close that gets me to the 258. When I do my multiplying here, I'm going to get 256. So that's perfect. 4 goes here, 256 down here. Subtract, I get 2. Bring down my 3. Now we've got 23. Well, every time I bring down a number, I have to put a number on top of my division. I have to try to divide. So 64 doesn't go into 23, which means it goes in 0 times. And now I'm out of numbers, so that means that 23 is actually also my remainder. So for my final answer, there were 140 rides in that given day, and there were 23 people on the last ride. So today's topic is going to be powers and exponents. I told you we're kind of gearing up for order of operations. We've done the addition and subtraction. We've done the multiplication and division. Today we're going to talk about powers and exponents. So first thing I want to address is a lot of times we kind of interchange the two words of power and exponent. And I just wanted to kind of clear the air up and really lay out for you exactly what is meant for each part. Okay? So first off, we use the term power to actually express what this whole thing is. This whole thing altogether is called the power. Okay, and its exact definition is that it is a product of repeated factors. Okay, and then a product is made up of 2 parts. The first part is the base. And the base is that factor that we want to repeat. And then this part, that is what is called the exponent. And the exponent tells you basically how many times to repeat your factor. A lot of times you might hear someone read this as 3 to the power of 4 or 3 raised to the 4th power. This 4 is actually the exponent. The power represents the whole thing altogether. it really doesn't matter. I just wanted to kind of clear the air about what it is supposed to be. But everyone knows what you mean, whether you call this the power or you call it the exponent. And that's really what matters. But I know there are some people out there that get a little confused about, well, which one is it? Is it a power or is it an exponent? Well, technically, it's all a power, and this is just specifically called the exponent. All right? So let's practice writing powers, finding values of powers, and writing them out. So I'm just going to fill in this table here. So our repeated factors, we have 4 times 4. So 4 is the repeated factor, that's the base, and we're repeating it twice, so the exponent is 2. And if I actually figured out what this equaled, it'd be 16. Next we have 6 times 6, so 6 is the base, 2 is our exponent again, and that equals 36. This time we've got a 10 being repeated, so that's our base, and it gets repeated 3 times, so it has an exponent of 3, and that would equal 1,000. On these ones, we're starting with the power expression, and we're going to write the repeated factors. So I should have 100 repeated 3 times, and that would equal a 1 with a lot of zeros after it. It should have 6 zeros, 3, 4, 5, 6, which means we're looking at 1 million here. Here we've got 3's being repeated 4 times, and that equals 81. And then we've got 4's repeated 5 times. This one I don't actually know off the top of my head, so I'm going to have to break this down. And here's what I'm going to do. I know that 4 times 4 times 4, so that would be 4 cubed, or 4 to the third, is equal to 64. And I know 4 times 4 is 16, so I'm just going to multiply 64 times 16 here real quick. I got 24, 38, add my 0, 4, 6, add these together, 4, 12, 10, so 1,024. All right, and last but not least, we've got 2's. So 2 is my base, and I've got 1, 2, 3, 4, 5, 6 times repeated, so that's my exponent. And then 2 to the 6th is 64. And the reason I know that off the top of my head is because I know 2 to the third is 8. So I just really have 2 8's here, which would give me 64. The next topic I want to, oh, wait a second. That shouldn't be there. Oh, and it's recording. Ah, okay, so, sorry. The next topic I wanted to address, it started typing, it wasn't supposed to, is perfect squares. So perfect squares is a term you hear, and it means any number that I can take the square root of, and I'm going to get a whole number answer. So for example, I know that 2 squared equals 4. This makes 4 a perfect square because the square root of 4 is 2, and I get a whole number answer. We could do this from 1 squared, that gives us 1, so 1 is also a perfect square. I could keep going down the list. 9's a perfect square, so is 16, so is 25, 36. Keep going with our common ones. 49. Whoops. 64. 81. 100. And so on and so forth. Basically, it's the number you get whenever you square a whole number. So there's an infinite amount of perfect squares, but they are very handy. They come in handy a lot later on, especially in algebra. So it's just something to be aware of, to kind of keep in the back of your mind, to know that phrase, perfect square, so that if it does come up again, you know what we're talking about. Okay, let's start wrapping up. We're going to do one word problem example for you today. We're going to be a little quick and easy. And then I'll leave you with one and we'll be all done. So the word problem I'm going to do, I'm talking about a Monopoly board. I'm sure everyone has played this game at least once. Been frustrated by, it's a hard game to play, and depending on the people you play with, it can not be very fun. Anyway, but a Monopoly board, standardly, is a square that has a side length of 20 inches. And we want to find the area of the game board. Well, it's a square. And finding the area of a square, we need to multiply the length times the width. In this case, that means we're multiplying 20 times 20. If we think back to how we write powers out, we have a repeated factor here of 20, so that would be our base, with an exponent of 2 because it's repeated 2 times. So we are just trying to figure out what 20 squared is, and that is 400. Since I'm talking about a measurement, I do need to label this. Area is measured in units squared, so I'm going to take those inches, and this is actually 400 square inches. And thinking back again, this 400 falls under that category of being a perfect square because it comes from a squared number. The word problem I want to leave you with, similar question. This time we are looking at a traffic sign. I want you to find the area of the traffic sign in square inches. Use the exponents to solve this problem. And as a little bonus challenge, also try to find the area in square feet. That's all I got for you today. A little shorter lesson. It was unfortunate it took me so long to get all the technology working. But next time we will hit up the order of operations. So we'll be doing review of the addition, subtraction, multiplication, division, and now the powers and exponents. And of course also give you the solution to that road sign word problem. Have a great day, everyone. I'll see you next time.